You may recall that in the past I did an experiment to see if I could do drip irrigation on my microgreens, and I considered that to be a failure. But lately I've been reading up on what's called flood and drain hydroponics, and I'm beginning to think that this may be a possible way to do this. The key to doing this is to have some way to attach a 1/4-inch drip line to the typical 10 by 20 trays. And the key to doing this is something called a top hat grommet, which is shaped like a top hat, which is why it's called that. This grommet is rubber. The diameter of the shaft here is just a little bit more than 3/8 of an inch, so it could be pushed through a 3/8 of an inch hole. The next part of that, of course, is to make a waterproof seal, and so far I'm finding that Gorilla Glue is a pretty good way to do this. It seems to react with water, it bubbles up a little bit, and makes a watertight seal. And here is an example of installing one of those grommets in a 10 by 20 tray. Basically, I drilled a 3/8 inch hole here, and then put a little water on it because water seems to be the catalyst for Gorilla Glue, and then put the glue on it and basically smeared it up and just put it in there and let it dry. There's also a piece of the 1/4-inch drip line in there, and I will be using an inline connector to connect that to a longer piece so it will drain back into the reservoir. Yeah, so you just see on the inside there how it kind of came through. The big white blob is a repair where I had tried to put this in with some acrylic varnish and it did not stick. The water got under there. So this is a 2-tray system, and the second part of this system can be a tray like this. And the other type of tray is this hole tray here, which has holes ready made. I had also cut these holes when I was trying out wicks. So it's going to be a question of what I'm growing, I think. Either one will work. I think that this kind of tray will be certainly better for peas because they tend to put down very dense root systems into the reservoirs when they get a chance. But I think either one of these will work. So the way this works is that if you put water into this tray faster than it can go out the little hole, then the level is going to rise and it's going to reach up and soak whatever you have in there. This is a pretty good sized gap, so let's just see what happens. This is going to pour a 1/2 gallon of water. I think it takes about a gallon in here, and you can see how it's kind of, the water has risen above the grid. So with just a gallon of water, I've got that whole fig covered, and when there's burlap and seeds on top of this, you can see that the water will rise up and soak the seeds. You can also see that it will take a few minutes for the water to drain out, so that's ample time for the seeds and the burlap to get soaked. At this point you can see that the water has pretty much stopped draining out of the pan, but there's still a level here, but it's below the level where the seeds will be, so they're not going to be sitting in water and getting rotten. At the same time, these will be able to reach down into the water and get all the nutrients they want. So this has something in common with the Kratky method, where you have some roots in water and some air roots as well. Here's the second method of attaching the top hat grommet, which is just to glue it to the surface of the tray. What I did here is I drilled an 1/8 inch hole, then a 1/4 inch hole, and then applied the Gorilla Glue to just stick it to the surface here and kept the holes lined up. I did notice that a little bit of the Gorilla Glue did get into the opening, and I used a Q-tip to swab that out, although that did leave some residue inside the tube. The thing is that if it turns out that this tube leaks, I can just seal it up with more Gorilla Glue. But this would enable me to really kind of fine-tune what goes on in here. Well, it's still going to come down to the level of this section here, but this could also be mounted like on one of these grooves possibly. It's hard to say if it'll seal, but then you'd have the ability to let it drain all the way to the bottom. Part of the plan is to possibly have a tube that feeds water into the tray as well as water out of the tray, But the thing is that the typical kind of pump used for aquaponics is a kind of a pond pump, and they are impeller pumps, which means that when they turn off, the water will tend to drain back out of the system. And so that could be used here as well, in order to let the water drain down to whatever level you want. Because with something mounted on the surface, you can really kind of control how far the hose comes up and set the water level that way. One of the things I learned yesterday is that Gorilla Glue does not work if you're trying to glue something to the outside like this. When I was rounding up some other pieces for this system, I knocked this off with no effort, and this whole area was covered with Gorilla Glue, just peeled right off, and it's coming off the rubber fitting pretty well. So, I'm basically going to have to use these things as intended. I drilled first a 1/8 hole, then a 1/4 inch hole. Now I'm going to expand it to a 3/8 inch hole, which is slightly smaller. And what you should notice, you saw the filings come off, and that's because the drill pulls them out. And this means that you want to drill on the outside, so that any burrs that occur are on the outside. So now the proper way to do this is just to push this through. So I had to ream that out a little bit more with the drill, but it's going to be a tight seal in there. So you just push the tube in, bring it flush with the surface where you want the water to end up. Okay, so that's all that is there, top hat on the inside. Now the pump I'm going to use for this is an Echo Plus 633. It's got a capacity of about 590 gallons. Of course, I'm not going to need anywhere near this. If I have this feeding 8 trays, it only takes about a gallon per tray. What I need this pump for is to reach the height that I'm going to operate at, and my top shelf is going to be at 5 feet. And so we can see that at about 5 feet, this pump will put out 159 to 211, somewhere around 175 gallons a minute at 5 feet in height. And this will be plenty to fill my trays, assuming other things work out, like feeding through the 1/4 inch tubes and so on. This pump only cost about $45 from my friends at Hydroponic Connection in San Francisco, so it's a pretty good deal. The other critical component of this is a digital timer. Not very expensive either, $10-12. The thing about this is that it will cycle on and off 8 times a day, and you can control the cycle time down to 1 second, which is exactly what I will need for this kind of application. One question about the setup of this system that has not been answered yet and will only be answered by experimentation is whether I will need to have both a feed line and a return line for each tray. As far as I know, these kind of pumps are impeller pumps, which means that when you turn them off, the water will tend to drain back down through the pump. And that's what I'm hoping will happen, that I can use a single line, a single tube to feed water into the tray to the level that I want, then shut the pump off, and the water will slowly drain out of the tray, soaking the plants, and then returning back into the reservoir.